today. And let's start off with this first example. I want to evaluate cosine of pi over 3 without a calculator. So I'm going to draw the special right triangle that we talked about last time. So cosine of pi over 3. I need the angle to be pi over 3, so I'm going to write or draw this triangle, where this angle is 60 degrees or pi over 3 radians. This angle here is definitely 90 degrees, and this angle here is 30 degrees or pi over 6 radians. This is your classic 30, 60, 90 triangle, or it doesn't sound as nice if you say pi over 6, pi over 3, pi over 2 triangle, but yeah, it's a 30, 60, 90, or if you prefer, a pi over 6, pi over 3, pi over 2 right triangle. I'm looking for cosine of pi over 3. So I have to remember the sides. So for a 30, 60, 90 triangle, or for a pi over 6, pi over 3, pi over 2 right triangle, the sides are 1, 2, and root 3. Okay, which of those numbers is the biggest? 1, 2, or root 3? I'll tell you, it's really easy to type in the chat. Yeah, 2 is the biggest. So 2 is the hypotenuse, right? Because the biggest side is always the hypotenuse. And then the way I remember which goes where is the smallest side, which is 1, always goes opposite the smallest angle. And the medium side always goes opposite the medium angle. In fact, that's a thing that's always true about any triangles. The smallest angle is always opposite the smallest side. The biggest angle is always opposite the biggest side. And the medium angle is always opposite the medium side. Kind of a cool fact. So in this case, cosine of pi over 3 is the adjacent side divided by the hypotenuse, which is going to be 1 over 2. And that's it. That's how did I get those sides? So last class, we talked about how for this particular triangle, the sides are 1, root 3, and 2. The way we got them really was by taking a equilateral triangle, which has angles pi over 3, pi over 3, and pi over 3, and then dividing it in 2. And setting, so I'm going to say I'm going to say this equilateral triangle, all the sides are also the same line. Let's make them all 2. And then I divide this in half. That's a right angle. This side gets divided in half and is now 1. And I can use the Pythagorean Theorem to find this other side and get 1 squared plus the height squared equals 2 squared. 1 plus height squared equals 4. So the height squared equals 4 minus 1. So the height is going to be the square root of 4 minus 1, which is the square root of 3. So that's how I get those sides. This is 1, this is root 3, and this is 2. And this is definitely a triangle you do want to memorize. So that's how we would find, that's how I would find cosine of pi over 3. I would think of the triangle and be like, oh, it's the adjacent side, which is 1, over the hypotenuse side, which is 2. In a similar way, if I want to find sine of pi over 3, well, I've already got a triangle there. Sine of pi over 3 is going to be the opposite over the hypotenuse, which is going to be the square root of 3 divided by 2. And that's it. Okay, so we're going to use this triangle along with the other triangle, the 45, 45, 90 triangle. Just those, yeah. I can also remind you of that real quick. So I could also ask a question like, find sine of pi over 4 and tangent of pi over 4. Again, you definitely shouldn't use a calculator to find sine of pi over 4. Not because you can't, but because, at least depending on the calculator, it might tell you that the answer is 0.707, which is an approximation. And we want the exact value, which is the square root of 2 over 2. So how do we get that? Well, we got the triangle. So the triangle here is this triangle. It's the 45 or pi over 4, 45 or pi over 4, 90. Where these two sides are the same length, I usually say they're both 1. And this side is the square root of 2. And again, the way we get those sides is by saying, well, we know these are the same if those angles are the same. And this side we can find using the Pythagorean Theorem. So then sine of pi over 4 is the opposite over the hypotenuse, which is 1 over the square root of 2, which we rationalize as root 2 over 2. And then tangent of pi over 4 is the opposite over adjacent, which is 1 over 1, which is 1. So that's how we get those values. So now, let's talk about the unit circle. There's the unit circle. It is a circle whose radius is a unit. In the real numbers, a unit is just 1. So the radius is 1, and the center is 0. And we're going to talk about a bunch of angles. So first, let's talk about, First, let's talk about the quadrantal angles, which is a word that I discovered teaching this class, which I really enjoy saying. So the quadrantal angles are just the angles you get at the end of each quadrant. So there's 1, 2, 3, 4 quadrants. We often label them as Q1, Q2, Q3, and Q4. And we start always at the, so right, this is the positive x-axis over here, right? This is x, this is y. The positive x-axis, the angle is 0. I'm using theta for my angle. And up here, right, if I go this much, the angle is, you can either say it's 90 degrees, but I'm going to use radians and say it's pi over 2 radians. If you go halfway around, well, again, remember the whole way around the circle is 2 pi radiuses, or 2 pi radians. So halfway around is going to be half of 2 pi, which is pi radians. Okay, and if we go down here, it's another, so it's 0, pi over 2 plus pi over 2, which is pi, pi plus another half of pi, which is 3 halves pi, or 3 pi over 2. And finally, all the way around, gets us back to 2 pi. Notice these angles 0 and 2 pi are coterminal, right? They end at the same spot. They have different measures, but they differ by a whole revolution. Okay, now we're going to fill in some other angles. I usually like to start with the pi over 4 because they're easy to draw. Where am I? Okay, there we go. So I want to draw like that. I kind of want to end it right. I guess it's better to end it right here. So here we have, this angle here is theta equals pi over 4. If I look at the angle, from there to there, that's a pi over 4. And then this is going to be, so pi over 4, 2 pi over 4, 3 pi over 4. 4 pi over 4, which is pi, 5 pi over 4. 6 pi over 4, which is 3 pi over 2, and 7 pi over 4. And what I'm doing right now is I'm drawing all what we typically refer to as the important angles when we talk about trig, or the special angles. So all of these angles are angles that we are going to be able to evaluate the trig functions of relatively easily and get relatively nice results. Let's do the other two types of angles. So we have the pi over 6s. So I do that a little too in the middle. Sorry. Should be a little bit more. Yeah. So there's theta equal to pi over 6. Or I'm really thinking so I know I'm using radians, but I'm still really kind of thinking degrees. The last one says 7 pi over 4. Yeah, sorry about that. Sorry, the writing is not always easy to read. Apologies. But it definitely says 7 pi over 4. So what I want you to think about before I get too into this is that the green angles all measure pi over 4 to the x-axis, right? From here to here, that's 1 pi over 4. From here to here, that's a pi over 4. From here to here, that's a pi over 4. From here to here, that's a pi over 4. And the same thing is going to be true for the blue angle, except to be a pi over 6. So this angle here, that angle measured to the always to the x-axis is pi over 6. And so when I draw it over this quadrant as well, it's going to be the same sort of deal. This angle here is pi over 6. Now, we don't really measure to that. We measure here. So if I go all the way from here to here, that's going to be 5 pi over 6. How do I know it's 5 pi over 6? Well, if I add one more pi over 6, I get 6 pi over 6, which is pi. And this angle is pi. And then I'm going to do that here as well. This angle is going to be 7 pi over 6. So I went one whole pi and then pi over 6 more. And then finally, the last one over here, that's going to be 11 pi over 6. Because if I went one more pi over 6, 11 pi over 6 plus 1 pi over 6 is 12 pi over 6, which is 2 pi. So I guess the other way around. So each of these angles in blue, if you measure or if you drop a perpendicular to the x-axis, you're getting an angle measure of pi over 6. Here, 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 and here. And then the same sort of thing is going to be true for these ones I draw in red. So that's going to be pi. This is not the red pen I wanted, sorry. Here's the garbage red pen. This is the pen I wanted. This one here is going to be theta equals pi over 3, or 60 degrees. And then on this side, same kind of deal. Except it's going to be a pi over 3 plus another pi over 3, which is 2 pi over 3. And then if I went one more pi over 3, I get 3 pi over 3. If I went one more pi over 3, I get 4 pi over 3. And if I went one more pi over 3, I get 5 pi over 3. If I want one more pi over 3, I get 6 pi over 3, which reduces to 2 pi. So obviously my picture is not perfect. You can definitely Google lots of unit circle pictures. But this is kind of the thing I keep in mind when I'm trying to figure out what quadrant an angle is in. So if I said what quadrant is 5 pi over 6 in, well, I'd look over there and say, oh, 5 pi over 6 terminates in quadrant 2. If I said what quadrant is 7 pi over 4 in, 7 pi over 4 is in quadrant 4. And here is the trick I have developed in my own mind to kind of think about it. These angles, these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 angles, right? Not counting the quadrantal angles. But these angles in blue, green, and red. These 12 angles we often ask about. What does that say 4 pi over 3 before 3 pi over 2? It does say 4 pi over 3. So all the red ones are something pi over 3. All the blue ones are something pi over 6, and all the green ones are something pi over 4. And the way I've always convinced myself or thought about how this works is that these are all the angles that don't reduce. Meaning, in the first quadrant, the pi over 6 angle is just 1 pi over 6. In the second quadrant, the next pi over 6 that doesn't reduce, well, 2 pi over 6 reduces to pi over 3, 3 pi over 6 reduces to pi over 2, 4 pi over 6 reduces to 2 pi over 3, and 5 pi over 6 doesn't reduce. That's the angle in the second quadrant that has a reference angle, or an angle that measures to the x-axis, which I know I haven't said reference angle ever we're going to, that is pi over 6. And then in the third quadrant, well, so then 6 pi over 6 reduces, 7 pi over 6 doesn't reduce. That's the angle in the third quadrant. And then the next angle that doesn't reduce isn't 8, 9, or 10, it's 11 pi over 6. So all of the angles that kind of matter are the ones that don't reduce. The same is true for the pi over 3s. Right? 1 pi over 3 in the first quadrant, 2 pi over 3 in the second quadrant, 3 pi over 3 is pi, it's not in any quadrant. Right? The quadrantal angles are not in a quadrant. I didn't always know that. 4 pi over 3 is the next one, 5 pi over 3 is the next one, and 6 pi over 3 reduces to 2 pi. And the same is true for the pi over 4s. 1 pi over 4 in quadrant 1, 2 pi over 4 is pi over 2, it reduces. 3 pi over 4 in quadrant 2, 4 pi over 4, 5 pi over 4 in quadrant 3, 6 pi over 4. 7 pi over 4 in quadrant 4. So what we're going to do is we're going to use the fact that essentially all of these angles have the same reference angle. And the reference angle are these dudes. In fact, before I get going on the next page of this, I'm not going to erase this just yet. I'm going to talk about the reference angles. So, what's a reference angle? Let me actually scroll down to here. Oh, that's not the right page. Sorry, one second. Holy smokes, did I close the one page I actually wanted to see? There we go, it's over there. Cool. So reference angles. What is a reference angle? Well, here's what it is. Reference angle is 1, always positive. Specifically not 0, right? It is always greater than and not equal to 0. It's always between 0 degrees and 90 degrees. Or if you prefer, and I do prefer, 0 radians and pi over 2 radians. And the way we find it is we measure to the closest x-axis. So for example, I could say, what's the reference angle, which often abbreviated as ref, what's the reference angle for theta equal to 140 degrees? Okay, I'm going to draw that. Start at the positive x-axis. There's 90, there's about 140. So if that angle is 140 degrees, if I drop a perpendicular to the x-axis, if this angle here is 140, what's that angle there have to be? Well, what do these angles have to add up to if we're going all the way around? Or sorry, halfway around, I should say. We'll have to add up to 180. So that angle there has to be 40 degrees. Right, exactly. Or what if I said my angle was 265 degrees? Well, 265 degrees is in the third quadrant, right? I go 90, 180, 270. Oh, 270 is too much. $265. And now here's the important thing to remember. We are never going to the y-axis. We are always going to the x-axis. So I drop a perpendicular to the x-axis. And I'm asking, oh, what's this angle here? Well, this is 265. This is 180. So it's the difference. It's 265 minus 180. Which is going to be 85 degrees. So the reference angle here would be 85 degrees. So between 0 degrees and 90, it's positive. It's measured to the closest x-axis. So if you're in the second quadrant, you're measuring down to the x-axis. If you're in the third quadrant, you're measuring up to the x-axis. If you're in your fourth quadrant, you're measuring up to the x-axis. Let me give 2 more examples of this. Sorry, yeah. We can also do it with radians. So, let's say my angle was, let's say it's, let's go 5 pi over 7. It's less than 1 whole pi, but it's bigger than pi over 2. So that's the thing, we have to kind of have an idea how these fractions work to know what quadrant we end up in. That's going to be in quadrant 2. Something like that. That angle is 5 pi over 7. So then I'm going to ask myself, okay, what's the leftover bit that gets me to the nearest x-axis? What's that angle there? Well, I know the angle halfway around the circle is pi. So to get from 5 pi over 7 to pi, I need 2 pi over 7. Or you could actually do the subtraction. Say, oh, pi minus 5 pi over 7 is 7 pi over 7 minus 5 pi over 7, which is 2 pi over 7. One more example. Say I had, say my angle was, let's say it was, sorry, now I'm trying to think of something interesting. Let's say it was 10 pi over, did I go the wrong way out? Let's do 11 pi over 8. Let's do 13 pi over 8. Sorry, trying to make up something that ends up where I want it to be. So 13 pi over 8. So here's pi, which is 8 pi over 8. Here's another pi over 2, which is 4 pi over 8. So far I've gotten 4 pi over 8, 8 pi over 8, 12 pi over 8, 13 pi over 8. So in this case, I'm trying to measure up to the x-axis here. So I'm trying to figure out what's this angle here. Well, that angle is, and this is where it's good to be good at fractions, right? I'm thinking, well, how much more do I need to get to 2 pi? Well, I need 3 pi over 8, because 3 pi over 8 plus 13 pi over 8 is 16 pi over 8, which is 2 pi. Or you can do subtraction, right? This angle here, right, here we have 2 pi. So 2 pi minus 13 pi over 8, that's going to give me this angle in red, which is going to be 16 pi over 8 minus 13 pi over 8, which is 3 pi over 8. So that's the idea of reference angles, is you're always just measuring to the nearest x-axis. Always the x-axis, never the y-axis. All right, so then, go back a little bit. We're going to use this to evaluate trig functions of angles that are not just pi over 6, pi over 4, pi over 3, but these other ones. And now here's a really nice thing. These other angles are color-coded for a purpose. If your angle is 2 pi over 3, its reference angle is pi over 3. If your angle is 5 pi over 3, your reference angle is pi over 3. Any angle that's red, the reference angle is pi over 3. Because from here, if you measure to the x-axis, the angle is pi over 3. Or from here, if you measure to the x, it's pi over 3. Or from here, pi over 3. And the same is true for any of the colors, right? For the blue ones, if your angle is any of these blue angles, the reference angle is pi over 6. So here, right, if you measure to the x-axis, it's pi over 6. Here to the x-axis, pi over 6. Here, pi over 6. And the same is true for the green ones. Green one, pi over 4. Here, if you measure to the x-axis, the angle is pi over 4. Same thing is true here and here. So the really, really nice thing about these angles specifically, this is not true for other angles, right? For example, for 5 pi over 7, the reference angle was 2 pi over 7. But for these special angles, where the denominator, where it's something pi over 3, or something pi over 4, or something pi over 6, the reference angle is always just 1 pi over 6, or 1 pi over 4, or 1 pi over 3. Which is really nice because we know how to find sine and cosine and tangent of those angles. All right, so let's look at some examples. All right, so let's say I want to find sine of 5 pi over 3 and cosine of 5 pi over 3. There's kind of a 4-step process here. So step 1, what quadrant are we in? Let's see. I know 1 pi over 3 is in quadrant 1, 2 pi over 3 is in quadrant 2, 3 pi over 3 isn't one of them, it reduces, 4 pi over 3 is in quadrant 3, 5 pi over 3 is in quadrant 4. So I'm in quadrant 4. Or you can also draw it. Say, there is 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. Quadrant 4. Okay, what's the reference angle? Well, you didn't even need to do really anything, at least after some practice. If you see 5 pi over 3, you're like, oh, it's pi over 3. Because it's one of my special ones. It's just 1 pi over whatever your denominator is. Again, I want to remind everybody, that's only really true for these special angles. If your angle is something like 5 pi over 7, your reference angle is not 1 pi over 7, it's 2 pi over 7 for that particular example. Okay, part 3, and this is the part I think that we haven't covered yet. No, not yet. Figure out the trig functions using the reference angle. So we know from our previous triangle work, right, from this triangle, where pi over 3 is the angle, and the sides are 2 and 1 and the square root of 3, we know that sine of pi over 3 is opposite of hypotenuse, which is root 3 over 2, and cosine of pi over 3 is equal to adjacent of hypotenuse, which is 1 over 2. So then the last part, and this is the part we maybe haven't talked about yet, we're going to use an acronym, which we'll talk about in a second. Use the acronym, and so, yeah, I'm going to say the thing and then we'll talk about why it works. So use the all students take calculus acronym to determine whether sine, cosine, tangent, etc. are positive or negative. So in this particular example, our angle is in quadrant 4. And in the 1, 2, 3, 4th quadrant, cosine is positive, and the other two trig functions are negative. So sine of 5 pi over 3 is going to be negative root 3 over 2. And cosine of 5 pi over 3 is going to be positive 1 over 2. And it might make a little more sense if I draw a picture. So here's what we're doing. We're saying, okay, there's my angle. Well, okay. There's my triangle. There's my angle pi over 3. Hopefully you guys can see that okay. Here, this side is 1. This side is 2. And this side is root 3, but it's actually negative y value. So it's actually negative root 3. This length is always considered positive because it's kind of like a radius of a circle, which is always positive. And this length is positive because we're on the positive x-axis side. So cosine of this angle is adjacent over hypotenuse, which is positive 1/2. And sine of this angle is opposite of hypotenuse, which is negative root 3 over positive 2. All right, so let's actually talk about that. I feel like I've done such a good job on this picture. I mean, I did a pretty good job. It's not the best ever, but it's all right. I don't really want to erase it, but I guess it's time to erase it. So let's draw another circle. And we're not done with these circles yet. Actually, let's not draw a circle just yet. So here we're in quadrant 1, here we're in quadrant 2, here we're in quadrant 3, here's quadrant 4. What I want to point out is that in quadrant 1, so let's say my angle terminated in quadrant 1. So maybe my angle is this, and here is my triangle that goes with it. Well, in quadrant 1, the adjacent side is positive, the opposite side is positive, and the hypotenuse is positive, meaning all my trig functions are going to be positive. So we have that sine is positive, cosine is positive, and tangent is positive. I'm not writing down the other three Because if sine is positive, its reciprocal is also positive. If cosine is positive, its reciprocal is also positive. If tangent is positive, so if every time a trig function is positive, its reciprocal is also positive. And the same is true if it's negative. If sine is negative, then cosecant is also negative. Okay, now over here in quadrant 2, well, if I draw a triangle in quadrant 2, and this is my reference angle, if I drop this perpendicular, this side now, that's negative, and this side is positive. So that sine will be positive because it's the opposite over hypotenuse, which is positive. But cosine will be negative because it's adjacent over hypotenuse, which is a negative over a positive. And tangent will be negative because it's opposite over adjacent, which is positive or negative. Same kind of thing happens in the third quadrant. In the third quadrant, let me use a different color here. In the third quadrant, if I have some angle like this, draw perpendicular, here's my reference angle, right? Now this side's negative and this side's negative. So sine is going to be negative because it's a negative over a positive. Cosine is going to be negative because it's a negative over a positive. And tangent is going to be positive because it's an opposite over adjacent, which is a negative over a negative. And finally, in the fourth quadrant, here's my reference angle. Dropping the perpendicular to the nearest x-axis, I can see that my adjacent is positive and my opposite is negative. So sine is going to be negative because it's opposite over hypotenuse. Cosine is going to be positive because it's adjacent, which is positive over hypotenuse. And tangent is going to be negative. Okay, that's a lot of work to say. I don't mind doing work, but it's a lot of writing to say the following. In the first quadrant, all trig functions are positive. In the second quadrant, sine is positive, and the other two primary ones are negative. In the third quadrant, cosine, sorry, not cosine. In the third quadrant, tangent is positive, and the other two are negative. Again, I'm not saying the other three because if these two are negative, the reciprocals are negative. If this one's positive, the reciprocal is positive. And finally, in the fourth quadrant, cosine is positive. So people often remember this by using the mnemonic device that is all students take calculus. In quadrant 1, all trig functions are positive. In quadrant 2, sine is positive. In quadrant 3, tangent is positive. In quadrant 4, cosine is positive. All right, so then we can answer other questions. Like, I want to find sine, cosine, and tangent of 7 pi over 6. So I want to ask you guys, what quadrant is 7 pi over 6 in? Totally, quadrant 3. So step 1, we're in quadrant 3. Step 2, our reference angle is what? Well, it's one of our special angles, so it's just 1 pi over 6, exactly. Now, if you don't like just saying this, you can also draw it, right? We can draw our picture. There's 7 pi over 6, right? It's a little bit, here's pi. It's a little bit more than pi. And then the reference angle, well, this angle is 7 pi over 6. This reference angle is just the difference, pi over 6. All right, thing 3. And so, sorry, the question was to do sine, cosine, and tangent. I know that sine of pi over 6 is 1/2. Cosine of pi over 6 is root 3 over 2. And tangent of pi over 6 is root 3 over 3. How do I know this? Because I know the triangle. I know, I'll draw it down here. I know my triangle, my 30, 60, 90, or my pi over 6, pi over 3, pi over 2. I know that the longest side is 2. The smallest side, which is opposite the smallest angle, is 1. And the medium side, which is opposite the medium angle, is the square root of 3. So I know that sine of pi over 6 is opposite over hypotenuse. Cosine of pi over 6 is adjacent over hypotenuse. And tangent of pi over 6 is opposite over adjacent, which is 1 over root 3, which I rationalized as root 3 over 3. So now I'm going to use the fact that we're in quadrant 3, where tangent is positive and the other two are negative, to say, oh, sine of 7 pi over 6 must be negative 1/2. And cosine of 7 pi over 6 must be negative root 3 over 2. And tangent of 7 pi over 6 must be positive root 3 over 3. And of course, you can just write root 3 over 3. I'm just writing positive to emphasize it. And to kind of expand on this just a little bit more, it's really because, right, I'm drawing this triangle here, right, where this angle is pi over 6. This side is negative root 3. This is negative 1. This is positive 2. So sine is negative 1 over 2. Cosine is negative root 3 over 2. Tangent is negative 1 over negative root 3, which simplifies to root 3 over 3. But I don't want to have to draw this picture every time. That's why I'm going to just try and make it simple by saying, identify the quadrant. That's going to tell us what trig functions are positive, what trig functions are negative. Identify the reference angle, and then use our knowledge of that angle and its triangle to figure out what the trig functions are for that angle, and then adjust the positive or negativeness for the actual angle we have. Let's do a couple more. Yeah, we got time. Yeah. So let's find tangent of 3 pi over 4. Let's do sine of 3 pi over 4 and secant, which is the reciprocal of cosine of 3 pi over 4. All right, so we know we're not in quadrant 1 because that's just 1 pi over 4. I should say also the angles in the first quadrant are always reference angles because they're always between 0 degrees and 90 degrees, or 0 radians and pi over 2 radians. This is in quadrant 2. Right, we're living the quadrant 2 life right there. So we know 1, we're in quadrant 2, where sine is positive and the other ones are negative. Our reference angle is pi over 4. It's probably my favorite reference angle because it's the easy one where sine and cosine are the same. Sine of pi over 4 is root 2 over 2. Cosine of pi over 4 is root 2 over 2. So then I know sine of pi over 4 is root 2 over 2. And I know that really because of the triangle, right? I know that my triangle for pi over 4 is the 1, 1, root 2 triangle, where it's opposite over adjacent, so it's 1 over root 2, but we write it like that. So I know sine is root 2 over 2, and the tangent of pi over 4 is 1 over 1. And I know that, so let's see, I know that cosine of pi over 4 is adjacent over hypotenuse, which is 1 over root 2. So I know that secant of pi over 4 is the reciprocal, which is root 2 over 1. So secant of pi over 4 is just the square root of 2. Square root of 2 over 1, but that's just square root of 2. So then, to find sine of 3 pi over 4, I'm just adjusting whether it's positive or negative. So sine of 3 pi over 4 is positive root 2 over 2. Tangent of 3 pi over 4 is negative 1, right? Because sine is positive in quadrant 2, and tangent and cosine are both negative, and so are their reciprocals. So if cosine is negative, so is secant. So secant of 3 pi over 4 is going to be negative. Okay. So the last kind of question we often like to ask in this context is, sometimes we don't give you an angle, and we still ask you to find things. So I know that seems kind of weird, but it is often something we want to do. I might say something like, for example, the sine of some unknown angle is equal to -3/5. And I know that tangent of that angle is positive. And I'm asking you to find cosine of the angle. Well, that seems weird. Can I go back? Sure. What's up, Sophia?
Sorry, I need to write that the last part down.
The secant of 3/4 is equal to -√2?
The number 4. Yeah. I'm good now, thank you.
Oh. So to solve a problem like this, I usually think about the right triangle. I say, okay, I know that sine is opposite of hypotenuse, so I'm going to draw it this way. I'm going to draw my angle like theta. Really, I'm kind of thinking of this as like the reference angle. So I'm actually going to say that sine is 3/5. I'm going to forget about the negative. You could also do it differently. You could say, well, I know, let's see. If sine is negative and tangent is positive, which quadrant do we have to be in? Can we be in the first quadrant? No. Can we be in the second quadrant? Also no. Right? Here, all things are positive, well, sine's negative. Here, sine's positive, well, sine's negative. Could I be in the fourth quadrant? Well, that's a good question. Sine's negative over here, but tangent's also negative because cosine's positive. The quadrant we have to be in is quadrant 3, where tangent's positive and sine is negative. So you could, if you wanted to, draw it like this, where the opposite's -3 and the hypotenuse is 5. But we can just adjust for the positive or negative sign at the end. So I'm going to do it like this and say, okay, well, I know sine is -3/5. I know tangent is positive. So I know that I'm in quadrant 3. Which means I know that cosine has to end up being negative. But to find cosine of this angle, I do have to find this side, which means I have to use the Pythagorean theorem. So to find this side, let's call it A. I know that A squared plus 3 squared equals 5 squared. So solving for A squared equals 5 squared minus 3 squared. So A squared equals 16. So that means that A is equal to 4. It's not plus or minus 4 because we just care about the positive side. We don't have to find both solutions here. This is going to be 4. I guess if you were doing it over here, you could say that this is -4 since we are on the negative x side. So looking at this triangle, you could say, oh, cosine of theta is -4/5. Or looking at this triangle, you can say, well, cosine of theta is 4/5, but then since we're in quadrant 3, cosine has to be negative. So either way, we get that cosine of this angle is -4/5. That's how we'd solve a question like this. And this is very kind of standard where they say, okay, I'm going to tell you one trig function of the angle. I'm also going to tell you another trig function is positive or negative so that you can determine what quadrant we're in. And then we're going to ask you for a third one. Let's do another one because we have enough time. The numbers are not always quite so nice. Meaning sometimes you have irrational numbers. They're not just nice integers like in this next example. So let's say we know that cosine of theta is equal to -5/6. And we're given that tangent of theta is greater than 0. what quadrant do we have? Well, I should say first, we're being asked to find sine of theta. So I want to point out, if you're ever given two trig functions that aren't reciprocals of each other, and you know that their positive or negativeness, you can always determine what quadrant your angle is in. So if I know that cosine is negative and tangent is positive, I can narrow down what quadrant we have to live in. So let's see. And definitely not in quadrant 1 because not all trig functions are positive. Am I in quadrant 2? No, because in quadrant 2, cosine should be negative, but tangent should also be negative because sine is the positive one. It looks like I'm going to be in quadrant 3 because tangent's positive and the other two, cosine specifically, is negative. And I'm definitely not in quadrant 4 because in quadrant 4, cosine is the positive one. So I'm in quadrant 3. So now I'm going to draw my triangle. So, okay, here's my triangle. Cosine is adjacent over hypotenuse. So it's the adjacent side over the hypotenuse side. Again, I'm ignoring the fact that cosine is negative when I draw this triangle. I'm going to use that to find the third side of my triangle here. Let's call this side B. I know that 5 squared plus b squared equals 6 squared. So b squared equals 36. Sorry, 6 squared is 36. Minus 5 squared is 25. So b squared is 11. So b is the square root of 11. There's nothing else we can do about that. It's just the square root of 11. We're stuck. All right. So then we're being asked to find sine of theta. Let me ask you guys, is sine of theta going to be positive or negative?
Negative.
Sorry, say that one more time. I didn't quite hear you. You were right. I just didn't quite hear it. I think you're saying negative, which it is. Right? Sine has to be negative because we're in quadrant 3, where tangent's positive and the other two, sine and cosine, are negative. So I know that sine of my angle is going to be opposite over hypotenuse. So sine of theta here is going to be negative, because we're in quadrant 3, opposite over hypotenuse. Square root of 11 over 6. And there's nothing else to be done. That's how our answer is. If we asked what tangent was, tangent would be square root of 11 over 5, and it would be positive. Not that that was the question, but I should just mention here tangent of theta is positive square root of 11